I'd like to present now how to obtain hydraulic data interpretation for generating heterogeneous hydraulic conductivity fields with SmartGEO. This application of SmartGEO was developed starting from the recent research activity in groundwater field, which asserted that the heterogeneous pattern in hydraulic conductivity in the aquifers can be inferred from the analysis and interpretation of hydraulic head measurements collected in field during perturbing events for the aquifer, such as the pumping test or hydraulic tomography test. The accuracy in mapping the aquifer hydraulic properties depends on the quantity and quality of data collected, and for more precise results, the pumping test should be performed in a tomographic arrangement through the use of several, even short pumping tests, which explore different portions of the aquifer. This is an example of a cross-well configuration of the hydraulic tomography, and this is an example of a multiple well configuration in order to obtain a hydraulic tomography test. In this example, we are going to show how SmartGEO can generate spatially correlated random fields of hydraulic conductivity which comply with hydraulic head measurements collected in field and with eventually available direct measurements of hydraulic conductivity. So we can go on and copy from the example, the SmartGEO project examples directory, the optimization file, and we copied it in a new working directory. We can open the Argus 1 interface, and the evaluation version is fine, and we can open the optimization example in the working directory selected. Okay, this example reproduces the same problem described in a second tutorial, but here we assume that hydraulic heads are actually measured in field during the pumping test in correspondence of the observing wells. So the observed head measurements are inserted in the layers called ops points and the name of the test for each scenario. And here we have 4 different scenarios because the hydraulic tomography consists in 4 different pumping tests. So inside the ops point test 1 layer, if we double click on this observing point called well 4, we need to fill all the fields with the time, the observing time, and the observing values, and the weight to assign to each value, to each observation value. The weight is a parameter which is utilized for giving, for instance, a smaller weight to the head measurements that are not reliable. In this case, we need to write, for instance, 0.1. Okay, for giving a smaller weight to this measurement. Okay. Since the inverse problem that we are going to solve is undetermined, SmartGEO looks for the optimal value of the hydraulic conductivity in correspondence of few pilot points, and then generates stochastically the hydraulic conductivity values in the rest of the domain. So in this kind of problems, of inverse problems, we need to activate the pilot point options. And if we don't have direct measurements of hydraulic conductivity, like in this case, we don't have to activate the direct measurements options. So in the pilot points layer, we draw the position of the pilot points. In this case, we have 4 pilot points called PP1, PP2, PP3, and PP4, which are distributed within the investigated area. And to each pilot point, we need to assign a name and a range of variability for the hydraulic conductivity value, so the lower and the upper limit. Okay, and for next steps, so for running SmartGEO and so on, please have a look to the second part of this tutorial. Thanks for your attention. Bye.